Okay, so I just finished extracting my telluric standard as well as my science target. And a really quick note here is we should know where these were written to. So it writes out a file for each one that has the output prefix of Spectra and then just the number that's left over here. So if we look at one of these images here, you can see the output spectrum, which is in the proc directory, is going to be Spectra and then the number that's the same as in here. Okay, so this is now the science target, so we can actually go on ahead and exit out of Spextool. For the next step, we're going to combine these spectra together, and to do that, we'll use xcomspec. So we can go ahead and type that in. Again, it's very nice that we can use numbers. So let's go ahead and we'll start with our telluric spectrum. So our telluric spectrum was 309 to 316. And I can load up all of the spectra. And now what we see is the spectrum of the object for each individual order. So that looks good. So the first thing that we're going to want to do is scale the spectra so that they match up and they can be combined. And to do that, I'd recommend picking an order that sort of is in the middle of the range, and then you hit the scale spectra. If you want to change, so right now it's taking the median over the region between these two dashed lines and taking the median of all of that. If you wanted to change that, the way you do that is in here, you hit S, and then you click on either side of the region that you want to do your median for the flux scaling. So if you think that looks good, you can go ahead and hit accept, and you can see that it has updated that now for all of the orders. Okay, so the next thing that we're going to want to do is prune the spectra. So you can see in particular, if you look at order 4, that one of our spectra here shows this really bad spike. And so if you see some areas that are like that in your spectra, we can actually go through and mask those out so that they're not included in the combination. So if I hit prune spectrum, oops, I want order 4. And I know that I kind of want to remove this particular one there. So what I can do is I'm going to zoom in on that by hitting X and then clicking on either side of where that noisy pixel is. We'll zoom in a little more. Okay, and you can see that it looks like this was maybe a bad pixel that was hit on several of the images. So it might be that this was a bad pixel that was showing up when the object was at this particular spot in the A images. Okay, so what we want to do is we want to mask that out, and to do that, we change that to mask, and we select the spectra that we want to mask. So it looks like we want the white one, the blue one, the yellow, and the orange. So yeah, so it looks like this was some kind of maybe a cosmetic error in the A position. Okay, so once I have selected the ones that I want to mask, what I do is I find the pixels that I want to remove, and I click S, and then click on either side of those bad pixels, and now for the spectra where those are bad, those are removed. Okay, to see the whole spectrum again, what I do is I hit W, and then you can kind of look and see if there's anything else that looks like it needs to be removed, and this looks pretty good. So we'll go on ahead and accept that, and now you can see it got rid of that bad section. Okay, so you want to go through and do that actually for all of the orders. Get rid of areas where there might be bad pixels, so those aren't included in the reduction. Once you have that, you can actually take a peek at what the combined image will look like. You can also take a peek at what your combined signal to noise is going to look like. Okay, so you can tell telluric standard, we have ridiculously high signal to noise for this particular object. All right, once you're happy that the combination is looking good and it's what you want, it looks like there's another one that I should remove there. But if you're happy with everything, what you can do is you can now write it out. And there are a few different types of statistics that you can do. And these are actually summed up if you hit this help button down here. The one that's most common that we're going to use is the robust weighted mean. This basically gets rid of outlier pixels and uses the uncertainties that were determined in the extraction to do a weighted mean. So you can play around with the robust threshold. Usually having it around 8 is fine. You can change it up a little bit, but that kind of changes how many spectra it winds up cutting out when it's doing the outlier rejection. And if we're happy with that, we can actually put in our file name. 4, 5, 6. Now at this step, I like to add the _comb as a part of the extension so that I know that this particular spectra has been combined. And once I do that, I can hit write file, and that comes through. Looks great. Okay. So once I'm done with that, I can now go and do this again for my science target. And all that I'll do here is put in my science target numbers here, 301 to 308. I can load those. So here you can see I have a case where order 8, there's not as much flux for this particular object. But I still want to go through and do the scaling and all of the various steps before I write it out. So once you have your telluric spectrum combined and your science spectrum all combined and put together, the next step is going to be doing the telluric correction, and that will be in the next video.